Chapter 14, number 73. The frequency of the standing wave shown in the figure is 185 Hertz. What is the fundamental frequency of the pipe, and what is the length of the pipe? So this is a pipe which is open at both ends. It's a little weird because we have antinodes at either end, and we've been talking about nodes at either end. But that's because they're probably plotting, for instance, density or displacement of the air, and we've been talking about pressure. So where there's a pressure node, we get the maximum movement of air, because to maintain the 1 atmosphere pressure, the air flows back and forth as much as possible. So anyway, what we have here is an open pipe, and our fundamental frequency in open pipe is from the antinode to the next antinode, because that's the simplest way I could have connected my open pipe. Maybe I should draw it like this. I should say if we had the fundamental would have to start at one antinode and end up at the other antinode. That's the simplest possible, which is 1/2 of a cosine curve. We have a complete cosine curve, so we clearly have 2 halves. Right, 2 halves of a cosine curve. And so this is an n equals 2. For open pipes or closed pipes or strings fixed at both ends, we can get every value of n. There's no restriction, so an even n is fine. Remember, for an open-closed pipe, the even ends drop out because they produce the wrong behavior at the far end. But here we have that the mode we're in is n equals 2. So we have that F2 is 185 Hertz. But we know that F2 is always 2 times F1. So that says the fundamental mode is 1/2 of 185 Hertz, which is 92.5 Hertz. So far we haven't actually used the fact that it was an open pipe or a closed pipe or whatever, because we know that F2 is always twice F1. But to get the length, which is part B, we're going to have to go through and say, okay, well, we know that F2 is 2 times V over 2L. That's the easiest way to do that, probably. So L is 2 times V over 2F, which of course is just V over F. We need a V, and following Walker, we'll just assume room temperature, which is 343 meters per second. Although honestly, you should have that specified. That's sort of a glitch on his point. This becomes 1.854 meters, but we only have 3 sig figs, so really the length is 1.85 meters.